How to evaluate a counting statistic. A counting statistic is just a simple numerical count of some item that you want to measure or talk about. So it could be something like 1 million missing children. It could be 3 million homeless people. It could be 3.5 million STEM jobs, where STEM stands for science, technology, engineering, and math jobs. It can be many different things. It's a very common type of statistic to encounter. They're particularly common in public policy debates. They're also used in marketing all kinds of goods and services, often to say there's a huge problem and our good or service is the solution to that problem. They can be very persuasive, especially when they're paired with an emotionally engaging story, something that gives you outrage, anger, fear, enthusiasm, something that personalizes it for you, a story about human beings. The number itself is usually not as effective, but if you have it paired with a really good story or a few really good stories, they can be very powerful in promoting a particular point of view and selling something and getting a public policy adopted. So they're very common. Counting statistics can be highly misleading and just completely false. They can be just made up guesses or numbers that are widely quoted, and actually when you try to dig into what they are, there's no real basis for them. They can also be completely accurate. So in this article I'm going to talk about 10 steps that you should follow to evaluate a counting statistic if you encounter one, and it matters to you, and that's one of the issues. We often accept these statistics because we're not that engaged. But first thing to do is to find out where the statistic came from, who actually produced it. A lot of news reports, blog posts, etc. may not give you a link to where it came from, or for example on the web you might get a link to another web story to another, and you don't actually have the original source. Ideally you want that original source. You want to know who produced it, exactly what they said, how they went about producing it, etc. So one of the most important things about a counting statistic is find out where it comes from. They're typically produced by people, or more often organizations, think tanks, marketing research organizations, etc. You want to know who those people are, who's paying for it, how much money they get from it, what's their track record, both in general and the specific field of the statistic. They might be experts in some other field and they aren't really that expert in the area of the statistics. Think tanks often have some kind of ideological bias or agenda. They're often funded by somebody. Very wealthy people and corporations are the source of an awful lot of funding of think tanks and other sources. That's true whether you're talking about right-wing think tanks or left-wing think tanks or all kinds of things. Sometimes it's quite unclear why they're being funded. Is it just altruism or is there some hidden agenda? One of the most important things about a counting statistic is to find out and analyze the definition of the item, like missing children, for example. What does that actually mean? In the 1980s, a figure of 1 million missing children each year in the United States was widely quoted. You still see it today. It was produced by rounding up from an official FBI number that covered a lot of different cases. A substantial fraction, maybe 100,000 or so children, are reported missing because of some kind of miscommunication situation. They went off to play with a friend and their parents weren't aware of it, or they thought they told them, or they forgot about it. So the parents report it to the police. Perfectly reasonable. Certainly not something to be too worried about in most cases. A very high proportion in the 1980s were actually teenage girls going off with a boyfriend, either without telling their parents or whatever. They would usually return. Perhaps a stressful occurrence for the family, but not a very serious thing. The million missing children number was often paired with stories of stranger abductions and murders, like the 1981 murder of 6-year-old Adam Walsh. There were quite a number of these that were reported. They were pretty rare, and they're still pretty rare, but they were paired with this very large number. If the statistic is actually paired with a specific examples and stories, which is common, it's very important to check if the stories that you're reading or the examples are representative of the data used for the statistics. And this ties in closely with the definition. So in many cases, you have a broad definition of the item being measured, the problem, if you will, which includes a lot of situations that we wouldn't be too worried about or aren't that extreme. It's combined with extreme, rare, and often horrific examples like in the missing children cases. It's really important to know if the story that you're getting is really representative of the data used to produce that statistic. It can be very inconsistent, actually. How is the statistic measured or computed? That's not always clear, and in fact, some statistics turn out to be a number that somebody just kind of said, well, what do you think is the number of homeless people in the United States? 3 million, right? It doesn't necessarily have a bunch of a basis. It could just be based on some activist or interested party or official who's not really thinking about it. That does happen and has happened. Once a number gets out there, it can be widely reported. It just becomes something everyone knows, and everyone repeats the statistic, and they don't drill down into where it came from. So it's very important to find the source of the statistic and really find out how they measured it, how they got this number. Numbers can be misleading because they have some sort of associated scale or context. So it's very common to encounter numbers which are multiples of a million, something like 2 million, 1 million, 3 million missing, or 3 million homeless people, 3.5 million STEM jobs. But what does that really mean? There are 7 billion people on Earth right now, or over 7 billion. In the United States, for example, there are about 328 million people in our country, and there's actually about 156 million people employed. So for example, if you say you have 3.5 million STEM jobs, which may be created by 2025, well, that's only a few percent of the 156 million people in the United States. And so that gives you some context or scale to evaluate the numbers. A million is a very large number. The vast majority of us don't deal with a million in everyday life very often. The median price of a home, which is one of the largest purchases that people make, for example, is something like $250,000 in the United States. Your total, if you do well in life, you might have a total net worth at the end of your life of $1 million. In the sense of your savings that you have to live on when you're retired or something like that. But that's actually a minority of Americans that have that much money by the time, maybe 10 or 20% of Americans that have even $1 million by the end of their life. Our everyday experiences with numbers like a few $1,000s for our rent or $500 for groceries this month. And our house, if we buy a house, and only about half of people do buy a house, it's probably our largest transaction, and it's very rare for it to be $1 million. It's usually a few $100,000 in most of the country. Even in very expensive areas like the Silicon Valley Bay Area, a lot of times the transaction is several $100,000. It doesn't get to $1 million. So we don't have a good intuition for what $1 million means, and $1 million is often being quoted in contexts where the appropriate scale is something like the population of the country. $1 million seems like a lot of money. If we're talking about the budget of the United States, which is several trillion dollars, it's tiny. A trillion is 1 million times 1 million. So $1 million to the government and for public policy purposes is frequently absolutely tiny. So it's important to note the scale appropriate to this number. Are there independent estimates of the same or reasonably similar statistic? If you only have one source, you have a single point of failure, something wrong with that source. If there aren't, why aren't there? Why aren't more people measuring this statistic? It's a fact that a lot of widely used statistics come from the government, and there really isn't an independent check on those statistics other than maybe other statistics the government puts out. So for example, the Bureau of Labor Statistics has a couple of different ways of looking at unemployment. One is called the Current Population Survey, where they go out and they ask people, are you unemployed? And something called the Payroll Survey, where generally larger companies report how many people are working for that company this month. These actually at times have produced different numbers, and both of them are being massaged or adjusted by statistical methods that supposedly compensate for weaknesses in them. And there's a lot of controversy because, again, there's a history of them sort of not lining up. The Current Population Survey shows low unemployment, but the Payroll Survey may show that the total number of people employed is dropping, which is obviously inconsistent. Another thing that's important with statistics is to look at other data and other statistics that you expect to be related. Do you in fact see the relationship you expect? For example, if you have a really low unemployment rate, you'd think that wages would rise, right? If companies are struggling to fill jobs, wages will rise. That actually hasn't happened much the last several years until quite recently, even though the government keeps reporting very low unemployment rates. And this gets into beyond the scope of this article. There's a lot of questions about the reliability of these official unemployment numbers. But the point is, the statistics should be consistent with other statistics and data that's out there. If it's not, why not? Can you come up with a reasonable explanation for why it's inconsistent? Is the statistic consistent with your personal experience or that of your social circle? the official unemployment rate is tiny, and yet you're unemployed, your friends are unemployed, they seem qualified, it seems like they ought to have jobs, that's an inconsistency. It may have an explanation. There's something about you and your friends that's atypical. You work in an unusual area that has high unemployment, even though most people are not unemployed. That might be the reason. But you need to ask yourself, well, does it match what I see? Do I expect this based on what I see? And if not, why not? The last is the most difficult criterion to apply, and that is maybe you just don't feel good about the statistic. You go through all these steps, you do everything seems okay rationally, but it doesn't feel right. You have an intuition like it's wrong. There's something is going fishy about this number. There is a lot of controversy scientifically over the reliability of intuition and what people sometimes call feelings, like saying this doesn't feel right, in the sense that I shouldn't do this or I shouldn't believe this because I have this feeling. I can't quite nail down what's wrong. Many people, and I'm one of them, have the subjective experience that a strong intuition often proves more accurate than a contradictory rational analysis. So you sit down and you say, rationally, this is what should happen, this is what should be true. Your intuition is like, no, 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 that's not what's going on. And later you find out your intuition was right. So I can't offer a certainty as to how to evaluate your intuition. One thing that appears to be true is that if you meditate on intuition or feeling, you sit there and you try to clear your mind and you just kind of think about it, kind of let it go, focus on that intuition, more concrete reasons for the intuition will often surface. You will often be able to identify why you have this feeling even though you previously couldn't. I've seen that with classification problems, like how do we tell if something's a dog or a cat? It's a subtle question, and yet people have a pretty good sense of what's a dog and what's a cat. And it's an interesting problem, but it's typical of these kind of things. As you think about it, you may realize, well, the vast majority of cats have a forward-pointing, kind of pointy ears. There are a couple exceptions to this. There are some dogs that do. There are other variations. If you start to think about like how you're telling apart dogs and cats and what the criterion is, you will start to see, okay, in most cases I do this. This is an exception, but it's because this other feature of the animal is very strongly dog-like, even though it has a forward-pointing ears. So certain dogs like huskies and so forth have forward-pointing ears. They're typically hunting dogs. The point is, again, often if you think about it, you focus on the intuition, say something's bothering you about the statistic, give it some time, sleep on it. Concrete reasons that are more defensible, you can verbalize what you find is wrong, will surface. So if you get to this point and you say, well, it just doesn't feel right, try that kind of process of giving it some focus, some thought, sleeping on it, give yourself a little bit of time, and see if in fact something comes to you as to why it doesn't feel right, and then go from there. So in conclusion, just to summarize, counting statistics are basically counting a number of something, like the number of missing children each year in the country, or the number of homeless people, or the number of houses in the country. They are very common statistics. They can have a lot of influence on our decisions, on public policy, on what we buy, particularly when they are paired with good stories, with emotional stories that engage us, things that make us angry, things that make us excited. So it's important to look at them and analyze them objectively and not be swayed by the stories alone. That doesn't necessarily mean the stories are wrong. In some cases, the stories are largely consistent with a statistic, and the statistic is well-founded in measurements and so forth. But often it's not. There's a long history of pairing of counting statistics that turn out to be very questionable with very powerful emotional stories that can sway you, they can get you angry and make you act before you assess the statistic. So this is how to evaluate a counting statistic. This video was produced on June 9th, 2019.